So, okay, class, for example number 1, the simply supported beam in figure A carries two concentrated load. Derive the expressions for the shear force and the bending moment for each segment of the beam, and then draw the shear force and bending moment diagrams. Neglect the weight of the beam. Note that the support reactions at A and D have been computed and are shown in the figure. So we have here the forces 14 kilonewton and 28 kilonewton. Both of them are concentrated loads, and RA and RD is already computed, which is 18 kilonewton and 24 kilonewton. If this class is not given, I mean the RA and the RD is not given, we can actually solve for that. We just do summation forces vertical and summation moment at any point. Then we can already solve for RD and RA. So we proceed. We have here the solution. The figure is shown like this, okay? So first, since we already have the reactions, we're going to cut the beam into segments. Dapat sa segment na yon continuous ang loading. So paano ba natin gagawin yon? Ganito, so in this figure, from A to B, di ba wala tayong nakikitang loading? Until such time dito sa point B, nagkaroon siya ng loading. Ang ibig sabihin, nagkaroon ng pagbabago sa loading at this point. So, tong A to B, it is considered already a one segment. And then, same is true from B to C. From B to C, wala tayong external loads until such time dito sa C, nagkaroon ng 28 kilonewton. So, ibig sabihin nun, class, nagkaroon ng discontinuity dun sa loading. Another segment for that. And that will be our second segment. And the last one will be for segment CD. Since wala namang external loads from point C hanggang D. Okay, that will be considered another segment. Magkakaroon tayo ng cutting plane between A, B, and then another cutting plane for B, C, and another cutting plane for C and D. Anyway, class, this method is actually your method of section. Meron din tayong tinatawag na method of area, and we're going to discuss that next week naman. Okay? So, next na. First, we're going to consider the segment AB. So, from 0 to 2. Ayan, from 0 to 2. Because this one is our first segment, diba? Nagkaroon tayo ng cutting plane, which is the cutting plane 1. So, ang magiging itsura niyan ganyan, class. Okay? Nagkaroon tayo ng cutting plane between those 14 kilonewton and our point A here. So, since pinutol natin tong part na to, from A to the cutting plane, that will be our X. And there will be a shear force at that cutting plane and a moment. We're going to analyze the whole system, class. If we're going to analyze the whole system, magkakaroon ng bending like this. So, there will be a positive shear and a positive moment. Diba sabi na pa natin ilalagay yung positive dito sa positive tong shear at saka tong moment. And diba dun sa sign convention natin, for the shear, it should be clockwise rotation. While in the moment, dapat kapag ka in-apply siya, in-apply mo tong moment na to, ngingiti yung beam. So that is the positive moment. So since meron na tayong ganito, no, we just need to do summation forces of summation forces y equals to 0, taking upward positive. So we're going to consider the left part of the cutting plane, class. Okay, it's up to you. If you want to use the right, it's okay. Okay, and you will still get the same answer, or this left, whichever is convenient. So in this part, we're going to consider this part, this left side of the cutting plane. So summation force is y equals to 0, taking upward positive. That will give us here the 18 kilonewton which is positive, minus the shear force here, and that is the negative. So therefore, we will arrive for a shear force that is positive 18 kilonewton. How about your moment? We're going to take moment, summation moment at this point equals to 0. Taking counterclockwise positive. Pwede nyo rin siyang gawing yung clockwise as positive. You will still arrive for the same answer, class. So, okay. So, taking counterclockwise positive at this point, we're going to have 18 multiplied by your x. So, that is clockwise. So, negative siya. So, 18 multiplied by x plus your m here, your moment here. That is counterclockwise, kaya positive. So, your moment, therefore, is equal to your positive 18x kilonewton meter. Ito na yung expression natin for the moment at segment AB. So, meaning to say, from 0 to 2, ito ang magiging equation ng moment natin. So next, i-consider naman natin tong cutting plane 2, which is your segment BC. So that is from 2 meters to 5 meters. So from point B to point C. Okay? So since kinat natin, magiging ganito ang itsura niya, class. Okay? Ang magiging x naman na natin this time is from the cutting plane, from the left part of the beam to the cutting plane. That will be your x. Kanina dito sa segment AB hanggang sa cutting plane, always from the left. That is your x. Okay? So, we consider again this left part of the cutting plane. So, we will do summation forces y equals to 0, taking upward positive. We have 18 minus 14 minus this shear force. And that will give us shear force of positive 4 kilonewton. Next is the moment. We do summation moment at F, at point F. Taking counterclockwise positive, we will have 18 multiplied by x. So 18, that is clockwise, kaya negative siya. Plus 14 ito. 14 plus positive siya, class, kasi counterclockwise. Okay? Counterclockwise kasi yung tinake natin as positive dito. Kinonsider natin na positive. Multiplied by your, what is the distance of F to this 14 kilonewton load? That is actually your x minus 2. Okay? So, plus your moment at F. At this point, okay? So we will arrive for an equation that is 4x plus 28 kilonewton per kilonewton meter. That will be our expression for the moment, or for the equation of the moment from 2 meters to 5 meters for segment BC to, class. So class, itong mga equations na to, kino-consider lang siya, I mean, applicable siya, applicable itong equation na to from 0 to 2 lang siya, from segment AB. And then, itong equation na to, applicable lang siya from 2 to 5, segment BC. And lastly, we have the segment CD, which is considering the cutting plane 3. That is from 5 meters to 7 meters. So, yan, pinutol na natin siya, class. Ito magiging itsura niya. Okay? Again, since pinutol natin, magkakaroon yan ng positive shear and a positive moment. And that cutting plane will be x distance from the leftmost part of the beam. Okay, and then we have, we're going to do summation forces y, taking positive, upward positive. So we will have 18 minus this 14 minus this 28 minus the shear force. So we will arrive for a shear force that is equal to negative 24 kilonewton. Constant yung mga shear forces natin, class. Okay? Yan ang magiging epekto kapag ang mga given loads is concentrated loads. We will have another example which will be uniformly distributed load later on. Okay? So, how about the moment? Okay? If we do summation moment at this point, the G equals to 0, counterclockwise positive, okay, we have here 18, negative 18, kasi clockwise siya, multiplied by X plus this 14. 14, ano ba yung distance ng 14 dito sa cutting plane natin? We have X minus 2. Okay? Plus this one, kasi counterclockwise din ulit siya, 28 kilonewton. So what is the distance? We have X minus 5. So that is the distance of this 28 kilonewton with the cutting plane plus your moment. Counterclockwise kaya siya positive, and that is equal to 0. And we will arrive for the equation negative 24x plus 168 kilonewton meter. So these are the expressions derived for the shear force and bending moment for each segment of the beam. For the part 2, sabi dun kanina dun sa problem, we need to draw the shear force and bending moment of the diagram. Diba dun sa procedure natin, sinabi doon, it is most desirable to draw the shear and moment diagram below the loading diagram. So, ganito dapat ang gawin nyo every time na magsasolve kayo ng shear and moment diagram, class. Ayan. So, this is your loading diagram. Below the loading diagram is your shear diagram. And below your shear diagram is your moment diagram. Okay? Your bending moment diagram. Ganito lagi yung magiging itsura ng mga solutions nyo later on. Okay? These plots, class, these are the result of the expressions that we derive. Itong mga to. Ito yung mga resulta niya. Ganito magiging itsura ng mga ito. Okay. Example. Itong segment AB from 0 to 2. Constant yung shear natin, which is 18 kilonewton. Kaya ito, nandyan siya, 18 kilonewton. Okay? And then from 2 to 5, constant ulit yung shear natin, that is positive 4 kilonewton. Kaya ito siya, positive 4 kilonewton. And lastly, for segment CD, constant ulit siya. And the value is negative 24 kilonewton. Kaya ito po ang itsura niya. Dire-diretso lang po yan. Since there is no discontinuity in between A and B, nagkaroon lang siya at this point sa B. Doon nagbago yung shear force dahil sa load na ito. Okay, how about the moment? How about the moment? Itong values natin dito, class, itong diagram na to, galing din ito dito sa mga equations na to. Okay, bakit dito 0? Our support here and here is, this one is a hinge and this one is a roller, remember? Okay, so alam naman natin na kapag hinge or roller, wala siyang resistance sa bend, sa moment. So, ibig sabihin, 0 ang moment at this point. Okay? Unless, dito sa part na to, ang given na support is fixed, magkakaroon na siya ng moment at this point. So, ibig sabihin, at this point pa lang, may pataas or pababa na siyang value. Okay? But since, sabi nga, hinge nga siya dito, so 0 po siya dito. Okay? So, considering segment AB from 0 to 2, if we have this equation, right? The moment is equal to positive 18x. If we substitute 0, kasi x yan, di ba? X yan yung distance, okay? If we substitute 0 here, our moment is 0, which is just correct, okay? How about if we substitute 2? Kasi hanggang 2. Hanggang 2 meters to, di ba? Then, if we substitute it 2 here, we will arrive for positive 36. So, that will be the bending moment at that point. Okay? And then, from 2 to 5, from 2 to 5, okay? If we substitute, dito naman tayo, okay? If we substitute 2 here, we will arrive, if we substitute 2 in this x, we will arrive for a value of positive 36. And if we substitute 5 here, we will arrive for a positive 48 here. Okay? So from segment segment CD naman, from 5 to 7, dito naman tayo sa part na to. Okay? We have the equation negative 24x plus 168. If we're going to substitute this value with 5, makukuha natin positive 48 sa class. Okay? And if we substitute 7 here, ang magiging value niyan is 0. Ganun po natin nakuha itong mga diagram na ito. If you want to make sure na, ay ma'am, paano po namin na sigurado na straight line po yan? You can actually, you can try it if you want. Kung masipag ka, you can substitute at this point. Since from 0 to 2 ito, gawin mong 1. Then, you can scale, you can try, and it will show you that it is straight line. Ganito kasi ang rule dyan, class. Okay? Kapag dito, walang slope. I mean, hindi nga siya 0, okay? Dito pa lang magzi-0. Dito magkakaroon siya, which is 0. Straight lang, constant. Plus 1 ulit, magiging yung slope niya magiging first degree na dito. Kapag dito pa lang siya, uniformly distributed load na siya. Dito, ang shear mo magiging slopey na siya. Magiging first degree na yung slope. Ibig sabihin, straight line siya. Magiging straight line in such a way na may slope. Since dito slope na yung may slope na, first degree slope na yung ano natin, yung shear natin, at this point naman magiging curve na siya, second degree na siya. Magpa plus 1 lang siya dun sa degree ng slope dito sa part na to. Okay? Hope you understand example number 1. We will proceed with example number 2.